This video is just a quick reminder about how to conduct multi-step analyses, specifically how to use the assignment operator, the equals sign, appropriately to conduct such analysis. So here I'm going to give you an example question, again using the MT cars dataset that we've been discussing. So the question is, what is the least fuel efficient car in the MT cars dataset? Meaning the car with the lowest miles per gallon that has 6 cylinders. Okay, so this is going to be a two-part question in the sense that our solution is going to involve two separate moves. So here we can think of the first step in our solution as focusing only on cars that have 6 cylinders, and then among that set of cars, sorting to find the car that has the lowest miles per gallon. Okay, to do that, in order to conduct the second step, we're going to need to save the results from our first step in an object. So I'll show you how to do that here. First, just to remind you what the MT cars data look like, we can run the head MT cars command to look at the data. And really, we're only going to care about these two variables, MPG and CYL. CYL tells us the number of cylinders. That's the inclusion criterion that we really care about. And then once we have the set of cars with only 6 cylinders, we're really going to be interested in this MPG variable. Okay, so making sure that we've loaded the tidyverse, because that is the package that contains the filter command that we need in order to look only at the cars that have 6 cylinders. We can first think about the code that we need in order to identify the 6-cylinder cars. So as a reminder, the filter command takes 2 arguments. First, we need to specify the data that we're interested in using, MT cars. And then second, the inclusion criterion that needs to be passed in order for an observation to be retained. Here, we want the number of cylinders to be exactly equal to 6. So to check whether a particular observation has 6 cylinders, we can use the equals equals sign. So this statement right here, CYL equals 6, is going to only retain observations for 6-cylinder cars. Now, keep in mind that this bit of code is only going to print this result. It's not going to save it anywhere. I need to save it, though, in order to do step 2, where we actually sort this resulting data. So the way to do that is to just add this bit of code at the beginning. So I'm going to create a new object, which I'll call 6.sil, and set that equal to this bit of code. So after I execute that, I have a new object called 6.cyl, which is just the subset of the MT cars data, which passes this condition. Then I can use the arrange command, this time on my subsetted data, to sort the data by miles per gallon. And then now I can see the thing that I care about, the car with the lowest MPG value out of the cars that have 6 cylinders. As an optional final piece, just to make the results really clear, we could save the results of that arrange command that we were just looking at as a new object, maybe 6.cyl.arr for arranged, and then ask R to show us just the beginning of that data. So by default, the head command will show 6 rows, but if we add an additional argument to this command, the (1), we can ask for just 1 row, for instance. So this is the row of data, or the car, that has the lowest fuel efficiency among 6-cylinder cars. The big point here is that if we're doing multi-step analyses, we're going to need to save the intermediate results as objects, which we'll then successively modify.